Have you ever pulled a package of meat out of your freezer, excited to cook it, only to pause because something looks off? The bright red beef or rosy pink pork you remember has turned dull, grayish, or brown in places. It doesn't smell bad, there's no visible mold, but it definitely doesn't look the way it did when you first stored it. That moment often sparks an uncomfortable question. Is this still safe to eat? Before you toss it in the trash, let's slow down, because that color change has a scientific explanation, and it's not quite as alarming as it looks. And today, we'll break down exactly why meat changes color in the freezer, what's really happening at a chemical level, and how to tell the difference between harmless browning and signs you should actually worry about, right here on History of Simple Things. Long before freezers became a household appliance, people were already wrestling with the problem of keeping meat fresh. Ancient civilizations used drying, smoking, salting, and even burying meat in ice or snow to slow spoilage. The Romans stored meat in cool underground chambers, while people in colder climates relied on winter temperatures to preserve food naturally. What they noticed even then was that meat changed color over time when exposed to air or cold. It wasn't until the 19th and early 20th centuries, with the rise of refrigeration and later electric freezers, that scientists began to understand why meat's color changes, and that the shift wasn't always a sign of danger, but often a predictable chemical process. To understand why meat turns brown in the freezer, we need to talk about what gives meat its color in the first place. The star of the show is a protein called myoglobin. Myoglobin lives in muscle tissue and stores oxygen for muscle cells. When meat is freshly cut and exposed to air, myoglobin binds with oxygen and forms a compound called oxymyoglobin, which gives beef its bright cherry red color. Pork and poultry contain less myoglobin, which is why they appear lighter, but the same basic chemistry applies. Over time, and especially during long-term storage, myoglobin changes. In the freezer, even though bacterial growth is dramatically slowed, chemical reactions don't completely stop. Oxygen trapped inside packaging continues to interact with myoglobin. As oxygen exposure continues, or as oxygen becomes limited and uneven, the myoglobin can shift into a form called metmyoglobin. This form reflects light differently, giving meat a brown or grayish appearance. Importantly, this change is about chemistry, not rot. Freezing itself plays a big role in speeding up this color shift. When meat freezes, the water inside muscle cells turns into ice crystals. These crystals can rupture cell walls, subtly damaging the muscle structure. Once that structure is compromised, oxygen can move more freely through the meat when it's thawed or even while frozen at fluctuating temperatures. The more oxygen that reaches the myoglobin, the more likely it is to oxidize and turn brown. Another major factor is freezer burn, which many people confuse with spoilage. Freezer burn happens when moisture slowly evaporates from the surface of frozen food. This dehydration leaves behind dry, pale, or leathery patches that often appear grayish-brown. While freezer burn can affect texture and flavor, making meat tougher or bland, it does not make meat unsafe to eat. The color change associated with freezer burn is largely due to oxidation and moisture loss, not bacteria. Packaging makes a huge difference here. Meat that's loosely wrapped, stored in thin plastic, or kept in packaging with trapped air is far more likely to brown in the freezer. Oxygen is the real enemy of color stability. Vacuum-sealed meat, by contrast, often keeps its original color much longer because most of the air has been removed. That's why professionally vacuum-packed meats tend to look fresher even after months in frozen storage. You might wonder whether browning means the meat has gone bad. In most cases, the answer is no. Browning alone does not indicate spoilage. Spoiled meat shows clear warning signs: strong sour or sulfur-like odors, a slimy surface after thawing, or visible mold growth. Color changes without these other signs are usually just oxidation doing its thing. In fact, many perfectly safe cuts of frozen meat look unappetizing but cook up just fine. That said, browning can affect quality. Oxidation doesn't just change color, it can also alter flavor. Fats in meat can oxidize as well, leading to what's called rancidity, which causes stale or cardboard-like flavors. This doesn't always happen alongside browning, but both processes are driven by oxygen exposure. That's why freezer-stored meat, while safe, may not taste as good after very long periods. Different meats brown at different rates. Beef, which has a high myoglobin content, shows color changes more dramatically than chicken or fish. Pork falls somewhere in the middle. Ground meat browns faster than whole cuts because it has far more surface area exposed to oxygen. That's also why ground beef often looks grayish-brown inside even when fresh. Less oxygen reaches the interior compared to the surface. If you want to prevent meat from turning brown in the freezer, the solution isn't complicated. It's about minimizing oxygen and moisture loss. Wrapping meat tightly in freezer-grade plastic wrap, using heavy-duty freezer bags or vacuum sealing can dramatically slow down oxidation. Labeling packages with dates also helps ensure you're using meat while it's still at peak quality rather than discovering it months later in the back of the freezer. So the next time you notice frozen meat looking brown or gray, don't panic. That color shift is your visual cue that chemistry has been quietly at work, not necessarily that something has gone wrong. Freezing preserves safety by slowing bacteria, but it can't completely freeze time when it comes to oxygen and muscle proteins. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.